So welcome everybody to the third day of Agility Prime. We have a really awesome guest for you guys today, and I will go ahead and introduce him. So today joining us will be Kyle Clark. He is from Beta Aerospace. Kyle is a pilot. He's an engineer and team member of Beta Technologies. Prior to Beta, Kyle led the creation, commercial launch, and sale of 2 power electronic companies, but his passion has always been aviation. Beta is a company Kyle always dreamed of being a small part of. He is loving every minute of his adventure and looking forward to the rest of the marathon. Also, just a quick mention, Kyle graduated from Harvard University School of Applied Mathematics and Engineering. So with that, I'm going to go ahead and let Kyle just introduce yourself, tell us a little bit more about yourself than what I already mentioned, and anything you have to say.
Awesome, thank you so much. And I'll try to be pretty efficient here. But I see some friendly faces on the hangout here. Good to see you guys, Rachel and Luigi, Sean. I think I can make it so I can see everybody now. This is wonderful. Yeah, thanks for joining me here. I think that I would love to just kind of talk a little bit about the philosophies that we have at Beta, share with you some of the work we've been doing, and then just have an open discussion about how we're approaching the Agility Prime mission needs and the aircraft development. So I'll be short on the front end and talk a little bit more on the back end. So I'm just going to attempt to share my screen again here, and if somebody can just give me one thumbs up so I know that you can see it, that would be awesome. Thumbs up. Can you? Oh, we've got one thumbs up. Thanks, Greg. Good stuff. So let's go here and just to extend on some of the stuff that I was talking about in the Firestarter, which, by the way, I think is a very inappropriate name for aircraft. The first principles engineering approach that we're taking to aircraft development really centers around the respect of the challenges associated with electric propulsion. And as many of the people on this call I know, we are really penalized in energy density. Although it is growing, we're still going to be struggling with getting to the energy density of liquid fuels. And I think it's important for us to recognize that electric aircraft does not just mean that we're storing it in batteries or converting, or doing some type of battery-based system. It could mean hydrogen fuel cells, it could be other types of batteries, and of course it could be overall hybrid systems. But either way, we need to carry a lot of energy and convert it efficiently. But as I mentioned before, and this is where we'll kind of jump into some of the stuff we've developed, this is a relatively low quality, now that I see it up close, the picture of a recharging pad. And I want to answer a couple questions that people commonly ask about why a recharging pad. And this stems from the recognition that storing 300 to 400 kilowatt hours of battery on an aircraft, and in this particular case, our aircraft is designed for a relatively long mission of 200 plus nautical miles. To make that system commercially viable, it needs to recharge very quickly. And over on the right side of this recharging pad is all of the flight test batteries from our first several campaigns acting as arbitrage or big buffers to the electric grid, such that when the aircraft lands to charge, the energy is actually sloshed from the stationary storage batteries over to the batteries on the aircraft. And the utility grid, most of which are fairly constrained because historically airports are not big consumers of power, sees a very, very small perturbation in its load, from a trickle charge to a trickle charge of the arbitrage batteries to a trickle charge of the aircraft batteries, with the majority of the energy being produced for the aircraft from the storage batteries. And what's really interesting about this is that once the aircraft leaves, because there's an active front end, i.e. a 4-quadrant inverter tied to the electric grid, providing 3-phase real and reactive power, we can then provide support services of the grid. And the dirty little secret of providing support services are that if you want to put a diesel generator on the grid to support things like electric car recharging or airplane recharging, and you want to swing up and down by a megawatt, you have to put a full 2 megawatts in, and you operate nominally at a megawatt, and you absorb some. You can't absorb any energy, so you just lower the production or you increase your production. With batteries, because they're bidirectional, you can both absorb and supply. So per nameplate, per megawatt we install, we can provide twice as much services, which means twice as much revenue for the recharging pad when it's on the grid. The other question I get is, why does it have an elevated deck? And in this particular case, this example is actually inside the side of fence of the Burlington Airport, not necessary to have an elevated deck. But in many, many cases at hospitals and parking lots and urban environments and industrial parks, the security of the landing zone, especially as we transition to unmanned flight, is very, very important. So the elevated deck provides that first and foremost. But the second effect is, in this case, for example, it provided our compliance with the FAA advisory circular on the approach and departure angles and clearance zones. So we don't have to go chopping down fences and trees and organizing 300 foot of clear area before you get to the pad. And that's a really big deal, obviously. The entire system. Yep.
Sorry to interrupt. We're at the 5-minute mark.
Oh, okay. Well, I'll do another 30 seconds. Talk about avionics, and I think I brought this up only to point out the fact that systems management in electric aircraft is significantly different than systems management in a turbine or a gas-powered aircraft. And so a huge amount of effort has gone into developing with the FAA's cockpit integration team, crew loading systems and other propulsion management systems. And I'll stop there. I think that a lot of this stuff is old information. This was our test mule of power electronics, batteries, motors, inverters, a couple hundred test flights on it. And this was our test mule that we used for developing ground power, recharging, and controls. So I'll stop there, and we can jump into some questions.
Thank you, Kyle. We've got a couple of questions, actually more than a couple of questions. You've got a lot of questions. First from Jeff, how are you addressing see/sense and avoid in cruise and in urban?
Yeah, so we have a philosophy that as pragmatists and pilots, that we're first going to cross the threshold of deploying an electric aircraft and then worry about those other things like sense and avoid. Fundamentally, we're tracking those technologies, the LiDAR systems, the optical systems, even ground-based cooperative systems, so that we can collect data from other sensory suites. But frankly, the primary development we're on is to fly a 6,300-pound aircraft with significant cargo on it, and not worry about sense and avoid yet, because it's going to be a piloted aircraft to start with. And in 2025, after we have this thing certified and rolled out, we will be adding those features. So we're providing the provisions right now, but not exposing those or exploiting them.
Great, thank you. Next question from Rachel. Hi, Kyle. I'm curious about Beta's involvement in hydrogen tech. Also wondering if you can further explain your trickle charging arbitrage and how it relieves the constraint of grid draw.
Yeah, so we are tracking fuel cell technologies and other hydrogen power systems, but our focal point, just to get this thing in the air, is around batteries. So we've met with several companies, looked at the specifications, and mostly shied away from it because of the reliability and complexity of those types of energy storage systems. With respect to the grid draw, every grid has a base load and a supplemental load that is usually consumed by very, very fast changing things like cycling pumps and compressors and presses. And that cyclical load at the top of the grid is usually serviced with peaker plants that are super inefficient, very expensive for the utility. So with the arbitrage batteries in the grid and the 4-quadrant inverters, which means that it can push and pull at any phase shift, real and reactive power, it can then be dispatched by the utility, and providers absorb that power to keep the grid frequency and voltage stable without having diesel generators polluting.
Okay, thank you. Probably one last question. If we've got more time, we'll do another one. But the next question is from Arush. Can you elaborate on what you said in the keynote about so many components not belonging on the aircraft?
Yeah, sure. It's my favorite question, actually. The unique airspeed and operational corridor of a vertical takeoff and landing aircraft tells us that we don't need certain things, flaps, slats, speed brakes, retractable gear, and that other things can be solved more elegantly, like gearboxes, liquid cooling, tilting wings, variable pitch props. And I'll just use that one last example of variable pitch props or articulating rotor heads. We found through extensive design studies that we made a big mistake on our first vehicle. We assumed that a tilting rotor, a thrust vectoring system, would be inherently more efficient because it was less weight, less components, and we could reuse for both cruise and hover. And our latter vehicle is a lift plus cruise, and the studies show very clearly that optimizing a rotor for lift and a different rotor for pushing allows you to have an overall net benefit in the efficiency of the vehicle, because the twist and the pitch, two very important and different things, can be point designed for lifting or pushing. And that allows us to say, you know what, we don't need that stuff. And we leave flaps, variable pitch props, thrust vectoring, anything that moves off the aircraft. And as I mentioned in the keynote, that makes for the lightest components because they don't exist, and the most reliable because they can't break. So our vehicle, it'll pick itself up with only 4 moving parts, and it'll fly forward with just traditional flight surfaces and 1 pusher.
All right, Kyle, one last fun question from Mark. It's rumored that you were once a professional hockey player. Is this true? And if so, how does this connect with the creation of Beta?
That's funny. I played on the U.S. junior team, and then went to college and played there, and then was drafted by the Capitals, and had a very, very short professional hockey career. But I think the interesting part of that, I guess, I could dig out 10 of them, was that when I had always dreamed of flying. I had built a ultralight in high school, and my mother burned it, so I didn't kill myself in it. Tried to go flying every chance I got at the local airport by helping the mechanics. But the day I got my signing bonus, I went straight to the airport and paid for my entire pilot's license in one shot, because it was a dream that I had always not been able to afford. So hockey kind of enabled my passion to materialize in flying.
Great.
Very awesome. With that, we will be breaking you guys into smaller groups. And in this place, you guys are going to be able to do a really fun interactive activity. So right now we have on the screen, as you can see, what our assignments will be for this interactive activity. So I welcome you guys to please take a picture of it. That way we can just keep it on our phones. And if you guys can just give me a thumbs up when you guys are done taking a photo of the screen. Okay, Steve.
Okay, is everyone ready to go into breakouts? Thumbs up? Okay, after the breakout session, if you can take a picture of the screen, we'll bring you back to this room before you go back to the Agility Prime main video. Okay.
Live stream.
Yep, great. Breaking out now. All right. Just a few more seconds. We're doing more breakouts. And those who joined us a little bit late, I think you're going to be hanging out with both Natalia and I. Hi guys, for those of you in the main room, you guys joined a little bit late, or either the breakout session feature didn't completely work. So if you have any questions, let me type them over chat, and we can also do the exercise here. Let me share the screen again. Oh, yeah, that's the right one. So let me do the participants and unmute you all. All right, guys. All right, you can all chat. So why don't we do a quick networking session and start introducing yourselves, having a chat.
Cool. My breakout room was empty, so I just I waited there for a couple of minutes and no one showed up, so I just
Okay.
My day job is I work for Synergy Software Design. We make data management software for inspections for the Navy. Been doing it for like 20 years, and we also make Spider 3D. It's a 3D visualization tool. Those same people. But just on the side for fun, I've been fascinated by aircraft for like 20 years or whatever, and I've been working on this very same problem we're talking about here for that amount of time. So I just have some interesting perspective. I have a little design, and someone to die in my notebook. That's all.
Great. Thank you, Greg.
Thanks.
Someone else like to go next? Have a chat?
And I work on a farm with my dad, so we own a farm up in kind of Washington area. And my big thing about like what you guys could consider about flying cars is payload and like hauling load, so you could actually like move materials to the farm and stuff.
All right, cool. What are you growing on that farm?
We grow wheat, garbanzo beans, or other known as chickpeas,
Yep.
broccoli, just a whole bunch of stuff.
Excellent. Thank you for that. Who'd like to go next? All right, maybe I'll introduce myself. I'm an innovation accelerator and program manager at AFWERX. AFWERX is producing and co-hosting the Agility Prime conference this week. I work on a multitude of projects with the Air Force, and we're excited that this has been a pretty popular conference virtually. It's the first virtual conference we've done. So if you can, to memorialize our Zoom breakout, just take your camera and take a picture. And if you could post it on your Twitter, LinkedIn, or Facebook, please use the hashtag AgilityPrime. Or email both to info@agilityprime.com. I am going to bring the group back in about, let me see, in about 2 minutes. So if you could do a post on Twitter, LinkedIn, or Facebook, that'd be great. So what we're trying to do is post a record on the number of breakout groups that we've done. But the more important thing is that there's power in action and there's power in sharing. So during a global pandemic and during this massive set of virtual discussions, it's a really great way for us to innovate and move forward and still interact in the way that we do in the physical world. So part of this exercise is really to not only to broadcast Agility Prime, but really to show the world that we can still participate and interact with each other on a virtual basis. And we want to be able to share that and show that. Okay, I'm going to bring everyone back. And the breakout rooms will close in about 60 seconds. Welcome back, everyone. Natalia, where should everybody go now?
Well, right now, I think we're going into another breakout room. Just gonna switch you guys up a little bit. And we will be touching on the second part of our interactive meeting. Correct, Jason?
I believe that we're taking a little time for everyone to post on Twitter, LinkedIn, and Facebook using the hashtag AgilityPrime. And after this breakout session, please go back to agilityprime.com. We're going to do a regroup of all of the breakout sessions. I believe that there's going to be just a roundup of what was discussed, some of the questions out there, to discuss our experiences with the breakout sessions and how we can do this virtually and still be interactive. And then that will round out the session. We've got a surprise guest, General Levitt, coming up soon. So I guess it's not a surprise now that I told you. But please go back to agilityprime.com to rejoin that stream. And thank you for your participation.
Yes, and thank you to a huge thanks to Kyle for coming over and answering those questions and giving a presentation. I'm sure most of us wanted to keep asking questions. I hope you guys are having a great rest of your day and just follow Jason's instructions. So we'll see you there. Bye, guys.
Bye.